Hello. How's everybody doing today?
Marco.
Doing okay.
All right. Sorry, I'm a minute late. The health of returning to the office. You have to walk between meetings instead of hanging up and logging back on. All right. Can you see my screen here?
Yes.
Yes.
Excellent. Give people maybe 2 more minutes to join. All right. I'm just gonna get started. Okay. All right. So kind of agenda for today. Got a little bit of pass downs. Gonna take opens. And then we want to kind of continue talking about that life cycle of the problems, the various homework assignments that a number of us took. Hopefully, we have some. So I've got around to do mine. And really, Enrico and myself have kind of sat down and looked at some of the work we've done last week and kind of created a list of debug activities. Extracted that from that. Yeah, so that's what I hope we can get to. Austin, were you able to look at the? I think you said you were looking at crashes, right?
Yeah, no, I ended up getting COVID, so I'm still
Oh no, sorry
having
to hear that.
chance. I did I'll look a little bit at it, but I had some questions kind of on the scope of it, but we can
Okay,
later, yeah.
okay, we can get to it. All right. All right. So let me quickly go get into a pass down. So, I had to move I essentially all the links to the Google Drive have moved. I had to yeah, there were some things about the way that space was organized that I initially didn't understand. That's why some of the links didn't work. Um, I fixed that, but as part of that, fundamentally all the links to the Google Drive have slightly moved. What's in the wiki is up to date, so if you have you know, looking for the recordings and the current link that you stored from 2 weeks ago doesn't work, that's why. Then the other one that's kind of passed down is Enrico and myself have a 30-minute presentation. Enrico, 30 or 20 at the OCP Summit. So I hope to see some of you there in person. I don't know if who of you is planning on traveling there.
Yeah,
Right.
I'll be there.
Ah, nice. Let's make a point of spending at least 2 minutes to put a face to the name.
Did we get what day we were on?
We're on Thursday.
We're on Thursday. Okay.
Yeah.
It may be one of those I just drive down.
Are you in the hardware management track, Marco?
Yes, I am.
Okay.
Yeah, I'll be there as well.
All right, excellent. All right, I'm gonna take opens. Want to see everything is clear and perfect. All right, let's jump. Okay, I'll keep this slide around. Okay, so what I've done is I'm gonna go into the. So I basically took my AR and took a look at the characteristics of handling performance issues. Um, and here's kind of the first thought I have. Okay, we're essentially looking at the system that's it's still up and running, probably running a customer workload, but it's not quite doing what it's supposed to, right? The throughput isn't what it's, performance of throughput isn't what we want, but really nothing has yet failed. And the system is likely running some customer workload operating on sensitive data. To me, that's kind of the that's sort of the characteristics of this use case, right? It's doing our thing, and we're seeing it being slower than we wanted to. Any questions on or additions to that? Okay, and then kind of as I look at that, right, then one of the things is really whatever we do probably shouldn't, must have minimal impact on the performance of the running system. We probably have limitations of what data can be extracted in that case, because it's might very well going back to probably it's a customer workload that's running on something sensitive. So the data we can get is probably limited. And then also what I mean by limited access is you're probably not allowed to like SSH into the machine and look around, right? That's kind of what I mean. Goes kind of in tandem with the the whole privacy consideration. And really,
Well, you're not going to want to SSH into it anyway while it's running. Right?
Exactly. Yeah, but I mean, in like in our case, right? If I do this, we get to interactive debug as one of the things I might be doing, right? and then really we don't want to disturb the workload in any shape or form, because hey, at least it's still running. Okay. And we go, Austin, any thoughts on the boundaries? What did I miss?
Yeah, I'm not sure. I'll have to think if there's anything else.
Okay.
Is there any space for trace, or is trace part of whatever telemetry, or where would you add that one?
Yeah. So logs base. Okay. If I go down here, it could be trace/logs, right? But yeah, let me move towards that, right? So, so when it comes to the reproducibility, right? I mean, I would assume that, well, my stance is, right, if it's at least on the tenant's workload itself, right, it probably reproduces at a decent frequency, because otherwise they wouldn't care, right? If it, your workload slowed down once and then recovered after 5 seconds and never showed up again, you're probably not gonna. This wouldn't probably make the list of problems to look. Wouldn't even make the list of problems to look at, right? So it's probably gonna reproduce at a decent frequency, otherwise it wouldn't be a performance problem in the first place. But as you go and move it into an isolated setting, right, the reproducibility might be more of a challenge, because you like, even if you have the let's say, I don't know, let's say it's a Twitter workload, right? pick on something. I guess it's X now. But okay, even if you had that customer was running that customer code in the isolation, right? You wouldn't have the same traffic of people people posting there all day long that you had on a truly running system. Does that make sense? I'm saying. All right. So if I look at the debug actions here, right, it's really the focus is really on observation, right? That's where you know, it's really logs, telemetry, as Wolf was saying, probably traces fall in. I will edit this and add the traces to the logs. Maybe I'll do this live. Maybe you go and extract the dump, but I'm not that one. I'm already not so confident about. And really, I think that the challenge is here's gonna be is have a way to get you know you know like this limited debug data that can exist in these sensitive environments or be extracted in these sensitive environments, sort of probably in the open, right? So it can be observed or can be audited, while simultaneously giving us an insight of what might be happening. Is there any thoughts on my description here? Or any thoughts on the slide before we jump to the debug actions in general?
Yeah, I don't know.
So-
Austin, go ahead.
Okay, yeah, I maybe this is included in logs, but I think yeah, of course, any of these issues, including performance issues, I think, you know, one thing is going to be to you know, be able to get and check the config, including, you know, primarily, and I think we talked about this before, making sure all the firmware is up to date and all that, of all the components is up to date and all that kind of good stuff.
Yeah.
So those to me are kind of the just simple hygiene checks that are just kind of should be done as the first step for almost any kind of anomalies, right?
Yeah.
The other thing too, and then maybe I'm highlighting something on your second consideration bullet, right? Nothing has failed yet. I mean, is this the point where we may turn on internal trace buffering so that we have kind of the, you know, the black box recorder-ish, just in case we do get to that failure?
Yeah, I kind of like
Because I mean, I mention that because I think one of the things, at least at this stage where the system is running, it's still running, you don't want to flood. I don't think you want to flood your management network with all this information, right? So some of the stuff that you're dumping or pulling out or looking at telemetry and such, it's maybe periodic. It's not huge dumps, right? So you may want to. So I'm assuming some of the larger other pieces of information you may be collecting on die or on package or whatever, right? Again, trying to not be intrusive though. But I know some systems do have, you know, maybe a circular buffer, so you can get, like I said, that recorder, you know, circular buffer recorder, if you will, of okay, I have X amount of time before the eventual crash happens, if it if it
No,
does.
if it even does, right? I mean, this could be like, this to me could be, perfectly steady state, right?
Yeah.
Might you got, you know, yeah, you're running at 3/4 of the throughput for some crazy reason, but it's been, you know, because it started Friday night and we don't work on the weekend, it's been doing this successful for 3 days now, right?
Yeah.
So it seems
That
like,
and yeah, and
this-
some of the other things too. I mean, if you're internally recording some stuff, I
Mhm.
mean, in some ways that could also generate events as to maybe some interesting points of when to do that, maybe dump extraction,
yeah,
right? And things like that. So it's a little bit more than you would the previous stage, and it's in preparation just in case
oh,
you
it
to
could
the
either be in
others.
preparation, or just to get more information about it, right? Because
Yeah, exactly,
we're running
exactly.
at, you know, 60% efficiency isn't good at all, right?
Yeah. Yeah. The other thing too that's interesting is, if it stays on the die, you may have a little bit more flexibility in what you can collect because it hasn't left yet,
Hmm.
right? You haven't extracted it yet, right? And the extraction is where you're going to run into all your privacy issues and things like that. So you may delay, you could potentially delay that issue and may have different ways to handle it when it's at a later time.
Yeah, it's actually also interesting. Yeah, um, you may want to actually have. So I mean, so is my thought. But no, like some of this data that would be normally streaming, right? Like logs, right? Um, you may want to, you know, um, collect them locally, right, and leave them to use your example and leave them on die, and then later get them at as kind of one package, so it can be, it can be reviewed and sanitized before giving it to the component supplier,
Exactly.
right? Yeah.
Yeah, exactly.
Uh, Something like that, right?
Yeah, this this is very to me kind of reminiscent of that flow we went through, I think, on the
Mhm.
CPU crashes, right? And they had this whole thing. It's like, oh, do we need to get this extended register dumps or trace dumps, right? So it looked like it had this kind of mechanism to do that. And then it also, when I was looking back at that thing, it also had to say, oh, well, you can save these things persistently. Um, there's persistent storage, so they could go be collected later. I I think and that's kind of one thing, and that I was looking at between all these cases. I think there's a great deal of overlap in all of
Mhm.
these use cases. I think the flow and what tools are available to observe and get debug and diagnostics will actually be um, very, very similar between a lot of these different cases.
You know, I agree, right? I think that it actually kind of takes us to the next topic of kind of the extracted debug activities, right? Yeah, I agree. We have all these use cases, right? But they're probably going to boil down to, um, you know, down to relatively few activities um, by comparison, right? It's not that we have, let's see, It's not going to be that we have, we have 5 use cases. They have, 5 debug activities each. So we have 25 things to wrestle with, right? It's probably going to be, five, five, 5 use cases that have 6 debug activities between them.
Right. So yeah, so like I think yeah, you have these handful of primitive things you can do, and those can be utilized by a host in however many different permutations to address however many different use cases.
Exactly. Which actually dovetails us nicely into the debug activity. So basically what me and then Rico did here offline, we kind of started from this picture and said like, okay, what are the debug activities here, and then overlaid it with the other things that we had already analyzed. And then basically the idea is as we go to the let's see, two remaining two remaining
Right.
cases, right? The boot crash and the crash handling, right? We would add to this list, or maybe not add to this list if there's nothing to add.
I could potentially add. Whenever you're ready, I do have my slides ready. My slide ready.
Peter, why don't you do that now? That sounds actually good.
Sure.
All right.
I have to share those. Sorry, I didn't send it to you ahead of time, and I was also making a couple modifications. Let me share.
Okay, I think I have to stop sharing before you can start, right?
Okay, it's been a second for me. 1 second. I can do this, guys. Even unless someone wants to point it out to me.
It's a green thing in the middle of the bottom bar.
Thank you. Literally,
Share.
says share. That's great. I think this should do it. Can use. Oh, nope. Did I actually click it? Can you see my?
It says no. I can. Yep.
Okay, let me make it. Oh gosh. Okay. What is it showing? Okay.
You're good, Peter.
Yeah, we see your slides.
Great. Always fun going to different technology. Okay, so I filled out the boot crash handling. So I think this will inform a little bit of differences on some of the debug activity. It probably highly depends on vendor capability potentially, but just in general, thinking about boot time errors that could happen. First, some outside actor like a BMC or some sort of debug pathway needs to be able to know that the boot is transitioning, that maybe progress of the boot, and then if there's any capability of presenting an explicit error, that the error information. So the way I see that, there's probably pretty historical means to determine that a boot is transitioning, kind of definitely vendor specific, definitely whatever part we're talking about. There's a couple ways to do that. These could all be all in one, the same mechanism for reporting the transition we are booting, to the progress of the boot and the boot error could all be in one spot potentially. So whether they're a signal, some sort of interface, some sort of passive stream, whatever it may be. Also, I'd point out that for proper analysis of a boot time error, of a boot crash or something like that, you would want to disambiguate the type of error that's going on if you have the ability to provide explicit error detection during boot. And so if you do, you'd want to provide the disambiguation also of the subcomponents, whether it be some hardware or software, firmware or software subcomponent. If there's something that says, hey, I'm a piece of firmware that did something wrong, if you need some way to disambiguate, this is more for the vendor for debug. I would expect this to be something the vendor would want for us to be able to convey. How much that helps the customer is maybe less important, but the customer may definitely be interested in if there's any hardware involved, or if there's an explicit way to determine that the boot was just halted because of some sort of hardware situation, right? And so in that, so either software or firmware, especially for the hardware, regardless, I would expect there to be likely some sort of affinity or locality within within the device. If there's anything like that, you'd also want to convey that. And then I do point out that having some sort of hardware or firmware software trace or stream we've talked about can be beneficial. I would just caution vendor specific, that it's not guaranteed that just saying I'm keeping track of the boot process implicitly implies you're going to see what the error was, right? So that highly depends on how the boot is tracked through the progress, whatever information says is provided for tracking. And so it could be advantageous, especially depending on the type of error that we're looking at or a boot crash scenario. But I don't know if that's always going to be the only thing we need. So I'll stop there for a second, make sure all that even made sense.
Yeah, no, made sense. The one consideration that's in my head, right, is you didn't talk about, like, especially an early boot, right? The you know, there's a limit. You potentially have limited facilities to extract the data in a in a higher level way, right? Like, for example.
Yeah, I put that in the boundaries. I said like
Okay.
available data likely limited due to performance or interactive mechanisms. They won't be online yet, right?
Exactly. Like,
I'm sorry, maybe it's a consideration. I didn't know we
yeah,
consider
no, it's fine. I don't think
Okay.
I did the best job of drawing the boundary between consideration and boundaries either. But that was kind of the thing that and then the other consideration is, like, it might not even be only the hardware vendor that's interested in the error cause, right? If I'm taking it, let me take the example of we fail to boot because the firmware fails to meet security checks, right? Like, that's that's something that was probably introduced by the CSP, and the CSP can potentially fix that by just flashing again, right? Or doing a firmware recovery if that's necessary.
Sure. Yeah, that makes sense. Yeah. We can put that, like, certainly, like, if there's an outside influence to the boot process that is dependent, like some sort of dependency, whether it be some sort of security mechanism or not. Otherwise, I don't know if there's like something that serves up the boot medium, something, thinking of like iPixie or something like that, if that's somehow involved, maybe that could be an element of this too, as a crude example. Some sort of external entity or actor that might not allow you to get enough data about why things went wrong. I could certainly, like, maybe put that. Anyone else on the considerations?
So this is mostly we talked about some of these that could apply to the system or the device. So this mostly focus on like server boot crash.
I mean, I'm sure. I mean, I would think that any device that you have access to it depends on the interface. It could be as simple as you get a signal that says I'm transitioning boot. It highly depends on the device, I suppose, right? I'm assuming, yeah. So sorry, your asked question is like assuming the infrastructure is like something in a server. I'm kind of operating that way. I'm assuming that if it's not got something like a BMC or something like that, then maybe it would be a device that's downstream connected. You could somehow extract this information. Let's say it's a PCIe card or something like that. whether or not this would be somehow supply the information through the normal, I'm not a PCI expert, so like through the normal PCI means, you could say, here's more data information, or some sort of side channel connectivity. But I'm certainly, hopefully I'm providing some generic things that help with boot crash handling. Whether or not all devices can supply all of this, I think there's a way to prune it to what you need. But if you want to have all the information, maybe tracer stream or something like that, maybe it's the only thing you can do. If you could like stream it to a localized buffer that's persistent across reboots or whatever, and hope that the boot, I point that out, if the boot doesn't come back, like if you can never recover this part, then right, we're talking about what can we do to increase our availability of this data. And so some of this is not guaranteed unless you have some mechanisms might not work if you don't have the ability to get back to it. Anyway, so sorry, hopefully I'm not trying to ramble. Hopefully that answered your question, or
Well, I think no, my question was more, I think, so what is crashing here? Right, it could be the server itself, so the whatever's running on the host CPUs crashes, so there's a full server crash. Or it could be that some component of some individual component that has its own firmware is trying to boot up and it crashes. And I was trying to figure out, is this intending to handle either one or both of those use cases or scenarios?
I'm mainly looking at like a component at the component level.
Right. Okay.
I'm assuming that once you get past a certain point, that the component is on a system, that system is resilient or not down. If the boot process, yeah. So like for example, security, like a secure boot process, is not quite in this flow or this consideration, right? So I'm not. I think. Go ahead.
Yeah, so I think, we talked last time about how a lot of these, could apply to either the main host or the individual components. And so like, boot crash, for example, it could be that you tried to boot up the system, some component generated a fatal error, and that ended up crashing the whole server, and then you need to go and debug an individual component, right? So that could be kind of one flow.
Yeah. So I would just say, like in that case, wouldn't that be some subcomponent had a boot time error-ish, but then the main system had a runtime error because of the boot time error of a subcomponent? I'm not
Well,
exactly
yeah, that's I guess it's maybe the terminology thing, at least for me, the system hasn't booted yet, so that would be a boot time crash from the perspective of the system, right? Even though each individual component may have finished boot. So that's why, and I had that question too. That was one of my confusions last time. Is like, are each of these applying to the individual component or the system? I think that applies to all, and I think
it applies to all of them. It just gets more complex as you get to the system. Let's say it's a server CPU. The server CPU is looking at downstream components coming online, and the server CPU now gets to a point where maybe one of them didn't fully complete properly, and the server CPU says, I can't move forward. Well, it's a boot time issue for the server CPU because of a boot time issue of the downstream component. I would think you can separate the two because each one has individual capability. Now, if you want to get fancy, then going back to my thing is, if there's a PCI card that's somehow enumerating but not actually fully like coming online or the way you expect it to, maybe there's something in your boot up process that on the server side you can say, I know it's there, but I need to get further in to see what's going on. I would expect we could maybe get fancier and talk about how you can provide this like, boot on boot, capability, right? Whether it's at the boot time of the CPU server CPU or not, I don't know that really matters, except for you could maybe capture that before you go trying to turn on the entire system. It could benefit you from saying, hey, I enumerated it, but I also know it's never going to come online the way the application expects it to because it's got a boot time error. If you can do that, right?
There's probably a couple of flavors of that, right? There's the let's just pick on a PCIe device, right? There's the flavor where the PCIe device never boots far enough to even attempt to enumerate, right? And then the server would maybe know that, based on, presence detect pins, there should be something in the slot, but nothing ever came online. And then there's probably the next flavor of it where, it partially enumerates, and then the server goes like, you ain't behaving right. I'm gonna basically isolate you and reject you to a degree, but I'm gonna continue booting myself. So it's potentially at least easier to diagnose what's happening.
And that's a good point too. This actually informs, like, if a PCI device is clearly not coming up, some of the recovery actions could be automated, because if you're doing this during like the system booting up, the system could take some proactive steps to reset automatically, capture the data hopefully, and reset automatically. So I don't exactly capture that in this, so that's a more system-wide kind of boot, like when you're having multiple sequences, multiple devices downstream. I'm not sure if that's kosher in the current landscape in terms of something that we do, but we could maybe talk about it. Yeah, so I did put the boundaries. I did kind of allude to it, then I didn't quite write to it. But most often the device itself is kind of my boundary. But then downstream, like a PCI card or interconnected devices, like interconnected similar devices. And so I put boot, the boundary is boot, but that could be, depending on the capability, it could be different. Maybe it's just early hardware boot. Maybe in terms of the point at which the boot is happening, which you're trying to capture the information. Maybe it could be enumeration, maybe the link training or whatever it is early or something like that. And so the hardware is involved. Maybe it could be at a more sophisticated step in the process where there's a full BIOS or board support package kind of running that can do more. And then maybe I put even further, like maybe even you go past the server boot and or something like that, or like some sort of host booting, and you now try to engage with this downstream device or whatever, and so you have some sort of early driver initialization that, even though everything all sounded good, there's some indication that it didn't actually work the way it was, or maybe there's even some driver problems, right? Not driver problems, but like driver device interaction problems. And I pointed out maybe it's a consideration, but I'm presuming that there's going to be times in these scenarios where the interactive mechanisms to get data are not available. So the boundaries are going to be limited to maybe potentially more passive data streams.
Yeah, and also let's say the mechanisms that are I don't know how I put it. Okay, I should say it this way. I know that at least some of us, even if it's just myself, right, like the idea of mapping a lot of those things into PLDM, right? But the stack may not be up yet, right? You may not be able to do these, more convenient things yet because you haven't actually got that far into the boot.
Right.
Yeah, and I think this is where I was going back before when I was asking about, is this talking about host CPU or device crash? And it sounded like it was talking about device boot crash. And in that case, I want to bring up, there is a spec that does cover that part at least. So there's well, there's like the OCP recovery spec. I don't know if you guys have seen that, but it talks about and then also NVMe has a mechanism to do this as well. But basically, in either of those protocols, there is a way where if your firmware can't boot up on your device, then there's a mechanism where, okay, at least if the ROM code was able to, the first code that runs, the first uh, static ROM code runs, and it's able to do stuff. It can at least give some indication to the host. And so like the recovery spec, OCP recovery spec, and NVMe have like a very primitive way to do this over SN bus, for example, right? And then the recovery spec also has a way where if you suspect that this boot failure may be because of bad or corrupted or incompatible firmware or whatever, there's a standardized way to go and reload a new firmware image onto it. But all this stuff is optional, but it's that could be possibly one avenue under the actions that a host may want to take.
Sure. Yeah. So if you can send the link to that, that'd be great if you can find it.
Yeah.
Yeah. Yeah, you can send them to the group. I add them to the minutes.
Right. Talk me all ears. Sorry about that. Okay, so just try to keep it across the board, addressing everything. So reproducibility, I put some statements that are more definitely CPU centric or whatnot. So if it's a CPU, there's definitely consideration for, excuse me, I started off with saying, if we had enough data, there may be enough information to go off of to not have to repro. I think this is a restatement of someone else's statements, but essentially avoiding a repro is a very positive thing with boot time errors because the next statement, which is, in some devices like a CPU, boot times can be very challenging in terms of how long it takes. And then also what it takes for the data center to even out for recovery, I can see it be challenging to run this through without it being a dedicated routine, which is less friendly to the customer having to kind of deduce this, right? So if you're just looking at, hey, I want to reboot a bunch of times, it just can be more costly is the bottom line. But that being one of the steps that can, for reproducibility, is primarily just reboot, right? Or reset, whatever it may be. So sometimes it can be costly. I also point out that, we did talk about, okay, maybe it's just a corrupted firmware. That's a little bit more straightforward. But in some cases, the issues could be due to defectivity or marginality such that it could be unreliable, this reproduction. So in boot time errors especially, I think that there's a higher likelihood of those types of events in terms of at boot, you're just initializing everything. You're going to find fresh errors compared to, the defectivity or marginality happens across the span of the different failures, but it may be that reproduction is harder to come by because of that initialization and configuration of the device. Does that all make sense? And is that hitting the right notes? Hopefully, maybe not.
Yeah, no, I think so.
Okay. Yeah, so I say, actually, these are the same thing. I'm not sure why I said the same thing. So logging the issue. Okay. So proactively, I think I would define that as s- that there is either there's an alert mechanism for a boot time issue, to either such as like upstream to the CPU or from the CPU to the BMC, either that or there's some sort of streaming or tracing that sends the data proactively, or there's some mechanism by which the data is provided, in a passive manner, either through the stream it has to be acquired, or there's some sort of data in a more primitive or maybe even more sophisticated interface. And from there, the actions, there's a number of them. I would say deeper level targeted diagnostics, they can either come from at boot time, potentially you can have some sort of parameterization of boot if possible, where you could change it to initiate some sort of diagnostic mode, where the boot comes up with more information, potentially. I'm just making stuff up as we go along. But I think I question whether or not that's always going to be guaranteed for all class of boot errors. But this would be potentially the only way to do it if the boot issue doesn't persist, which is the next one. If it's an option to do runtime diagnostics, potentially, if you can get it to boot, if it's a transient boot issue, right? And you could not run more targeted diagnostics.
And you leave yourself breadcrumbs that haven't gotten wiped out by the reboot, right?
Yeah.
So I mean, that's the nature of resetting and rebooting, right? That you're starting from a clean 0.0.
Yeah, I didn't put that out there, but there's also the potential to have the device itself, maybe in more limited cases, the mechanism for offloading or accessing the information, it just isn't there. And you could maybe have something stored within the boot, within the boot medium or the device that's persistent across the boot. And you just hope that it wakes up far enough along that it can present that information. I guess that's another option. I feel like that's non-ideal, and I wouldn't rely.
Yeah, I mean,
But I think that the
there,
actions you could take if you can do runtime diagnostics could potentially be sufficient helpful. Depends on the issue, boot time issue.
yeah, I mean those records corrupting could be the cause of the next boot failure, right?
Sure.
In the worst case.
Yeah, I put two. Obviously, updating firmware is potentially a common thing. There could be other obvious actions, like I said, at the top of the reproducibility. It could be an indication of something that's very well known by the vendor, and you just have an action to take. So that's another one. Just go and do this. Could just the normal thing of could be errata, could be whatever. And then simply, that's not a great one, but you could simply reboot. But then further, I would say that boot time is also a rich opportunity for vendor analysis, especially if there's not an explicit error information. I'd say boot is very vendor specific, and so my guess is it's highly beneficial to consider that there's whatever data you present is going to be more beneficial to the less on the diagnostic side, maybe more on the debug side. And so you might have definitely higher rate of scenarios where a debug of the issue is necessary. So just having a mechanism to send this off for further analysis. So what I got. Hopefully.
Yeah, I mean the one opportunity, right? I think it goes with the last thing you were saying, right? Is that since you haven't even completed booting yet, right? There shouldn't be any confidential information in the system yet, right? So
yeah, I was gonna say
that's that point, right?
it's more rich our environment to just provide as much data that won't break the vendor's secretiveness, but it should be. I would say that the caveat there is even at boot time, there could be keys like security keys that are stored by the customer. So you wouldn't want to expose any of that, which could be a part of the boot time failure potentially, or just even part of the process.
Well, it just depends on where in the boot flow those things are taken, right? Or they're distributed or downloaded or whatnot, right?
Yeah.
I
Yeah,
mean,
I would assume that we don't want that to be the normal course.
yeah.
In
I mean,
that.
just getting those secrets might have been the issue that caused the crash, right? And especially if it has to get it
Yeah,
from
so you'd
some
want
off
control
die or
control data that says I got this stuff, right?
yeah.
And then I died. Something that would convey that.
I think you well, we may be kind of limited in the data that can be collected even from pre-boot for a lot of components, just because I think we talked about this before, but some data centers they won't let the data go out unless they can see it in plain text and verify that it doesn't have any user data in it. And so even if you had like a system boot time crash, if you want to pull debug data and send it to the vendor, then you may be limited to just what's available via plain text in some scenarios.
Sure. Yeah, that's where the benefit, and I point out in the considerations at the bottom, having a trace or a stream of an entire boot cycle can be advantageous. But
Yeah.
the stuff above, I think, is more critical. Did we boot? Where in the boot are we? Even that the customer might have problems with. And most importantly, can we articulate boot errors? The customer will be happily able to, if you can tell us the interconnect between the package actually incurred an error. Like, okay, you can tell me, they should be able to tell me that, right? And they want to tell me that, like something about the interconnect is wrong. Okay, well, it's not customer secret, it's your part's wrong. If we can provide enough information around that on explicit errors, then I think that's a big step in the disambiguation process that's more acceptable. I think it is tricky. Like there's vendor specific stuff. You can make it plain text in that, hey, it's doing the same job of disambiguation of maybe the subcomponent. I think even accepting that, and that may be enough and be beneficial to the diagnostic. But there you do still have challenges to the tracing content, and boot progress could land there. Although I honestly feel like in the CPU world, that's like you have postcodes. Does anyone know, are CPU postcodes something that don't get published? Sorry, not published. They may not be published, but to customers. Is there any evidence in the industry of lacking acceptance of like a postcode trace, like on a BIOS or something like that? I don't know. That would be indicative.
I know we used to publish like back in the olden days when we had like the 7-segment LCDs with the postcodes. Yes, we published publicly every postcode and the meaning for our systems, but we have much more sophisticated ways to log the boot progress of the server today, and so we do have, at least on our end, I assume other server makers have pretty sophisticated ways to get boot trace logs and all that kind of good stuff.
Sure. Yeah, with the earlier pre-BIOS set environment, I would assume though there are opportunities to have similar types of capability. So I just wonder if if there's precedent there, then it just highly depends on the customer's acceptance of it. But yeah. Okay.
Yeah, well, and one, I'm still sorry, a little bit confused here because I thought it just so going back to is this talking about server host CPU boot crash versus device boot crash? I thought I heard you said it was more on the device side, but then it sounded like this was really more talking about the actual server itself failing to boot can you clarify one more time for me which flow this was mainly tackling?
I mean, this is being like super generic here, and with representation from a bunch of different people. From a device side, the means to convey the top level, that the boot has happened, that the boot is progressing where it's progressing in the boot era. I think it's any device. It's applicable to any device. And disambiguation isn't for any device. I don't think that needs to be that there's a BIOS or a, and then I point out it could be some sort of hardware based thing. It could be a BIOS or BSP type of thing. It could be some sort of driver and hardware interaction, something like that, where the driver's interacting with it. I see that as CPU, device, whatever it may be. And then the reproducibility is a little like, okay, maybe it's not costly, although I put it as it can be costly. Maybe it's not always costly to reproduce, like, reset the device a bunch. And yeah, I mean, I don't know. I don't feel like anything is super limiting to so like saying that it's only applicable to CPU.
Well, it was maybe to clarify this. Like so to me, there's like two different boot ups. The main, like for example, let's say you're booting the main server and it crashes. It doesn't even get to the OS, right? That to me is like kind of a system level crash. After you're booted up and you're running in the OS, you could reset an individual component. And that individual component's running firmware, and that firmware, while it's booting, could crash.
Yep.
And so this is kind of meant to handle any of those scenarios. Okay.
Absolutely.
Okay.
I can think of both cases. I think it can heavily depend in terms of the interface available, or if it's a PCI device versus a, I don't know, bespoke piece of hardware that's somehow interconnected to the system, whether it's a microcontroller. I'm just thinking of even a microcontroller, we could go that low, right? Because maybe that is ultimately what you're talking to early on, is maybe you're talking to a microcontroller as part of this process, and it could have a reboot that's super limited, like, hey, I'm in brownout reset or something like that. I have a firmware background, so like I think of very limited data that can be made available, all the way to a sophisticated performance or interactive piece of interface, down to like in the middle about some sort of hardware register set, some sort of hardware register access. Yeah, I feel like it can apply to all of it.
Okay. All right. Great. Thank you.
All right, that's good. We're at the top of the hour, so Peter, if you can send me your slides, so I can kind of have them all in one deck, and then next week hopefully Austin is ready, and we're gonna talk about either case. Hopefully you have time to talk about the debug activities. Thank you everybody.
Thanks.
Bye.
Bye.